All right, good afternoon. Welcome everybody. So you've got about 8 people on right now. It is Monday, April 6th. We're going to be doing 3.1 and 3.2 today. Let me just check Canvas really quick. So as of right now, or well, as of before I started class, yeah, there wasn't any questions on 3.1. So I'll sort of point out the important things here. Yeah, we have 10. So for 3.1, we have our quadratic functions or quadratic expression, and then we have to put it into standard form. And we do that by completing the square. And so once it's in the standard form, this guy here, ax minus h squared plus k, this tells us a couple things. First of all, it gives us the vertex, which is hk. So again, just our IHOP, whatever's inside is opposite. So whatever's inside the parentheses, it's the opposite value. That gives us the vertex. If A is positive, it's a parabola that's pointing upward. If A is negative, it's a parabola pointing downward. And then the tricky thing from this section is this guy here, the maximum or minimum. So the maximum or minimum value occurs at the point when x is equal to negative b over 2a. So we don't plug in b and a, and that value is the maximum or minimum value. That just tells us where it occurs. So then we have to take that value, plug it back into the quadratic function, simplify that, and that'll give us what the maximum or minimum value is. So is there any questions on that? Anything from the video didn't make sense? This is usually the tricky part. Probably this will be one of the concept questions for exam 3. So, with a quadratic function, I don't know, negative b over 2a tells us what information, or gives us what information. The maximum value, the minimum value, where the maximum or minimum value occurs, none of the above, things like that. So it's where it occurs. So everybody's okay with that? We got about 13 people on right now. So no other questions from this, from 3.1. Again, nobody posted anything on Canvas, so I'm assuming there was no questions. So let's get to 3.2. So 3.2, again, no questions came up from this. So I did get, Daryl, your question about the assessments. So we'll go through that. I'll kind of talk about 3.2 for a little bit. With 3.2, it's graphing polynomials. And so to do that, we have the following steps. The first step is we want to find the zeros, or sometimes they're called the roots. And we would do this by factoring the polynomial. So I believe in section 3.4 maybe. It's one of the sections coming up here in chapter 3. We learn how to factor a polynomial. And so we're going to do that. We're going to find the zeros or the roots. And when we do that, something called the multiplicity. So we'll find the roots and we'll find the multiplicity of those roots. We will find the Y-intercept. And we do that how? We do that by setting x equal to 0. Third one is we're going to determine our end behavior. And so in the last class, somebody pointed this out. So I'm going to give all due credit. Alejandro is his name. Give all credit to him. So we can figure this out by adding our multiplicity. So if one of our roots has multiplicity 2 and the other has multiplicity of 3, 2 plus 3 is 5. So our end behavior acts like x to the 5th power. And any even, so x squared, x to the 4th, x to the 6th, etc., those are parabolas. You're going to either start in the upper left, end in the upper right, or start in the bottom left, end in the bottom right, depending if it's a parabola pointing up or down. And then the odds, x to the 3rd, x to the 5th, x to the 7th, etc., act like x to our 3rd. Remember, that was our snake graph. So it's going to start in the bottom left. If it's positive, start in the bottom left, end in the top right. If it's a negative x to the 3rd, it'll start in the top left, end in the bottom right. So we determine end behavior. That's how we know where it starts and stops. And then lastly, we can sketch it. And I definitely mean sketch. These things aren't going to be to scale. They're probably going to look pretty ugly by the time we get done with them, but you're going to sketch it. Let me make one mention about multiplicity. If a factor or a root has multiplicity of 1, it's just going to cross the x-axis. All of these things talk about the behavior towards the x-axis. If multiplicity is even, so a root has 2, 4, 6, 8, etc. multiplicity, it's going to bounce off of the x-axis. And if it's an odd multiplicity greater than or equal to 3, so to the 3rd, to the 5th power, to the 7th power, etc., this is going to snake, as I call it, through the x-axis. So it's going to come up towards the x-axis or down, kind of level off a little bit, and then continue going up. It has that like x to the 3rd look to it. Flattens off and then goes again. So any questions on this? I'll leave this up here for a minute so you guys can copy this down. You guys are quiet today. Who's all on here? So I know at least who's here. Nobody's on today? Nobody wants to tell me? Are you guys getting this feed, hopefully? Oh, there we go. Okay. Hey, Amber, Daryl, Andrew. Okay. Just making sure. Nobody had said anything, so I wanted to make sure everybody was on. Okay, that's good. Glad to see you guys. Welcome in. Hopefully you had a good weekend. Don't know if we have any Casa de Papel fans. Came out on Friday, so I didn't get to bed till like 1 in the morning, binge watching that show. If you haven't seen it, you have time, definitely worth checking out. All right, so I'm going to erase this. If you guys haven't gotten it all written down, you can always go back to the video later, pause it if you need to. But I know it's my absolute favorite show on Netflix of anything. So, wait, did you change your name, Jonna? Wasn't it it was different last week, I think, right? All right, everybody have this, or if you need me to hold on a second, go ahead and type exclamation point. Otherwise, I will erase this and we'll move on to some stuff here. Okay. All right, so erasing this. So let's look at an example, and I'm going to call it our attendance example today. So, hey, Brianna. So again, like last class, if you would be so kind as to put this on in your ticket out the door notebook. This will be the attendance question for today. So we want to sketch the following polynomial. P of x is equal to x minus 2 times x plus 1 to the third power. So since nobody had a question, or at least that they posted on Canvas for this section, I'll let you guys try this. Then we'll walk through it together, make sure that we're all on board what we have to do here. But if you want to, go ahead and try this. When you finish it, just type done. If you have a question you need me to answer, go ahead and type that in as I let everybody try to solve this one. But for right now, I'll give you guys a few minutes to try to sketch what this guy looks like. And again, once you get done, just go ahead and type done. That way you guys aren't waiting on me to make some progress here. So. Also, as you guys are working this, so I did get feedback from a bunch of you on the discussion thread. If you still want to post feedback, that's perfectly fine. The thread is still up. I do appreciate the feedback. So for now, I think we'll stick with this format. As I mentioned in the write-up, I don't really like talking at you guys. That's why I love doing the flip class, because there was more sort of interaction. But this definitely has some advantages to it. So we'll stick with this for now. It doesn't mean we can't change later. If we run into issues with this or something later on, then we can always switch it up later. But it seems like from the general feedback, you guys like this format. You like being able to go back and watch it. You don't have to deal with some of the WebEx issues. So we'll stick with this for now. So again, once you guys get this sketched, or you think you have it sketched, just go ahead and type done, so I know you guys are all ready. Okay, Shelly. Yeah, it's about another minute or so here. All right, so let me go ahead and work this one. Like a few of you are done. I don't know if the rest of you guys are working or just holding on. So the way we would process this through, the first thing we want to do is find the roots. And again, if this thing wasn't already factored, we would have to factor it. Otherwise, we're taking these middle pieces. So x minus 2, set that equal to 0. X plus 1, set that equal to 0. Actually, let me move this off to the side here so I can graph later. So the roots, x minus 2 is 0, x plus 1 is 0. So that means x equals 2, x equals negative 1. So these are my roots. I'm going to circle them so I don't confuse it with the multiplicity later. So these are the points on the x-axis that this graph is going to do something. It's either going to cross through it, it's going to bounce off it, it's going to snake through it. So then multiplicity. For x minus 2, this is to the first power. So anything to the first power has multiplicity of 1, which means it's just going to cross through my graph. And then for x plus 1 has multiplicity of 3. So that's going to sort of snake through the graph as it gets close to the x-axis. Next, I need my y-intercept. So I'm plugging in 0 for x. So I have 0 minus 2 and 0 plus 1 to the third power. So that's negative 2. 1 to the third power is 1. So just negative 2. That's where this graph is going to go through the y-axis. And then lastly, end behavior. So again, the hint is just add your multiplicity. So 1 plus 3 is 4. So this thing is going to act like a graph that's just x to the fourth power. X to the fourth is a parabola. So I'm going to start in the upper left. It's going to do a bunch of stuff and it's going to end in the upper right. So I know that as I'm sketching this graph, that has to at least be one of the features. The next feature, y-intercept, is going through negative 2. And then my points on the x-axis is negative 1 and positive 2. So now I just have to connect where I'm starting with where I'm ending going through here. So first off, I'm going through x is negative 1. It has to snake through there. So this guy probably comes down, levels off, and then heads back down still. So it's snaking through the x-axis. Has to go through the y-intercept. And then the last thing it does is go through x equals 2, and it just crosses through. So from here, it just does that. So again, I'm starting in the upper left, going through x equals 1. It kind of snakes through, it flattens off and goes through my y-intercept, and then goes straight through x equals 2, ends in the upper right. So more or less, that's what your graph should look like. Again, it's a sketch. Yours might look a little different depending how flat or how wide your lines are and stuff, but more or less, that's what it should look like. So any questions with that? How we find any of the information, why the graph is acting a certain way? Any questions you guys have, just hit an exclamation point or a couple exclamation points, and I know that you're typing a question for me. All right, so I'm assuming no questions. So maybe that's good. Maybe you guys just understood this from the get-go, and that's great news. As far as the exam, obviously I can't give you graph paper and say graph this. So I may have to end up just maybe giving you like a choice of 8 graphs or something, and I have to pick the one that looks the most, well, pick the one that represents like the polynomial I give you or something. So some of these topics here that we're doing now might be a little more difficult to do on the exam 3, but we'll try to figure it out. So All right, anything else on 3.1 or 3.2 before I get into some of the assessment questions? So a couple of questions on the assessment. Didn't look familiar to what you had seen. So for number 6, you had f of x is equal to 6 minus 3x to the third power. You have to find f inverse. So what do we do for our inverse problem? First thing is change this guy to a y. Then get f by itself. So the first thing is to subtract 6 from both sides. So we get y minus 6 is negative 3x to the third. Divide everything by negative 3 to get x by itself. So we get y minus 6 over negative 3 is equal to x to the third. Now, if we think back to some of them that we did last week when we had like x squared equals something, or the square root of x is equal to something. So if I had x squared, what did I have to do? I had to take the square root. So if I have x to the third, how do I get x all by itself in this situation? What do I have to do to get x by itself? John has it right here. So we're going to take the cube root. So if this was x squared is equal to something, we would take the square root because it's to the third power, I need to take the cube root of both sides. That gives me x is equal to the cube root of y minus 6 over negative 3. And so f inverse of x, I have to change all the x's and y's, so I get the cube root of x minus 6 over negative 3. So remember what this whole problem is doing. We're just reversing everything. I have a plus 6, I have to minus 6. I have a negative 3 times this guy, I have to divide everything by negative 3. And then I have an x cubed, so I have to take cube root. And that would be the same for 12 and 13. We'll look at those as well. Any questions on this before I move on to the next one? And if so, just hit the exclamation point. I know to stop while you're typing the question. Okay, so number 12. So 12, you have f of x is equal to 2 plus the cube root of x. So similar to the last one, but just the opposite process. So again, we switch everything to y. I want to get x by itself, so the first thing I have to do is subtract 2 from both sides. And so now the last problem I had x to the third power, so I had to take the cube root. Now I have the cube root, so what do I have to do? Well, I need to cube both sides. When I do that, cube root cube, they basically cancel each other out, so I just have x, and this side becomes y minus 2 to the third power. Any questions on that? Does everybody understand that part? So it's the opposite of the last problem. The last problem we had x cubed, so I had to take the cube root. Now I have x cubed, so the only way I can get rid of the cube root is to cube both sides. So your F inverse is now just change everything to x. So it's x minus 2 to the third power. Okay, good. And again, so this would be a nice one on a test because we can check it, right? By plugging this back into here. So let's do that. Remember I told you you can always check these, and I would on the exam. You'll have plenty of time. So if I plug that in, I get what? I get 2 plus the cube root of this guy, x minus 2 to the third power. So the cube root of this cube means this piece just becomes x minus 2 plus 2. 2 minus 2, they cancel out. And I have just x, which tells me that I have this right. Because remember, if I plug an inverse into the original and simplify it, I have to end up with x. That tells me that I have the correct inverse. So questions on that one? So do you still need 13, Daryl, or now 13 makes sense? You'll just have to square both sides because you have the square root. So I'll tell you what, since we got a lot of time here, let me give you guys number 13. You might have already did it in the assessment. That's okay. More practice isn't going to hurt. We have f of x is equal to 2 plus square root of 9 plus x. So go ahead and try that. You're good? Okay. So never mind. Well, you know what? Go ahead and try it. So again, practice isn't going to hurt. So try this, get the inverse, plug it in, and check your answer. See if you get that it works out to be equal to x. And again, once you guys have it, just hit done. That way I know you're done, and we'll move on. I'll give you guys your ticket out the door, and I guess you get done way early today, so that's okay. I'll post another discussion thread for Wednesday's homework. Yeah, so if you guys have questions on that, make sure you post it on there with the screen print, then I know. While you guys are doing this, I'll see if Bambi or Ginger wants to come make an appearance today. Ginger, come on. So I had to bribe her with a treat, but Ginger's coming in today. Come on, sweetie. All right, you want to meet the class? Oops. Come here. Hey, come on this way. Okay, wait. So here's Ginger today, my little shepherd husky mix. All right, go back to sleep. You know. All right, so looks like people are wrapping up. Okay, watch out, beep beep. Come on, Jeannie. Go, go, go. There you go. Okay. Yeah, she's I think about 60 pounds, something like that. So super fluffy. She still has her winter fur, has to get rid of it for the summer here. All right, so what do? Change this to Y. Subtract the 2. So you should have Y minus 2 is square root of 9 plus X. And now again, we need to get rid of that square root. So we have to square both sides. So we get Y minus 2 squared is 9 plus X. These guys cancel out. And now subtract 9 from both sides. So X is Y minus 2 squared minus 9. So F inverse, just change everything to X's. So X minus 2 squared minus 9. So any questions on that? How to get the inverse there? All right, then let me give you guys your ticket out the door. So it's 2 problems. Give them to you, give you guys some time to work it. Again, you have plenty of time. So once you think you have it, just type done. So take it out the door. Number 1. So sketch P of X is equal to X plus 1 times X minus 3 squared times X minus 1 to the 5th. Number 2, if R of X is equal to X plus 1 over X squared minus 4, then what is the X-intercept? What is the Y-intercept? What is the vertical asymptote, if there is one? Whoops, let's see. And D, what is the horizontal asymptote, if there is one? So go ahead and try those. Again, once you're done, just type done, and after a handful of people have it, I can put the answer on the board. If you do have a question, feel free to put the question up as well. And then I'll answer that for you. All right, Shelby, I'll put up the answers in a minute here for you. Everybody else still working, I assume? If you guys do get done, okay, Amber, good. If you guys get done, just type done, then that way I know I can start putting up the answers for everybody. So I'll start working it since some people are starting to finish up. Again, if you don't have it done yet, that's fine. I'll hang around online here. So if you are still working it, you have questions, you can get it answered. So the first thing we want to do, we're going to want to find the roots of this guy. So it's -1, +3, and +1. The multiplicity is 1, 2, and 5. So that means it's going to cross through here. It's going to bounce off of this guy. It's going to snake through this one. The y-intercept, if I plug in 0, I get 0 plus 1 is 1. 0 minus 3 is -3, that's squared. And 0 minus 1, so -1 to the 5th. So this is 1 times 9 times -1. So -9 is my y-intercept. Okay, good, a bunch of you getting finished. And then end behavior. Excuse me. I have my multiplicity. It's 1 plus 2 plus 5, so that's 8. So this is similar to x to the 8th, which is like a parabola. So if I draw this, my different roots are at -1, +3, and +1. My y-intercept is way down here at -9. And again, because it's like x to the 8th, it's starting up here, has to end in the upper right. So what's going to happen at -1? So where it's crossing is -1, 1, and 3. So at -1, it goes straight through down to the y-intercept. Then I come back up and I hit x equals 1. So it's kind of snakes through there. So it comes up, flattens off, and then starts heading back up again. This is probably more so like this. And then lastly, at 3, it's going to bounce. So it's already above the x-axis. It's going to turn around and bounce, and then finish in the upper right. So your picture should look something like that, more or less. And then this guy here, my x-intercept. X-intercept, I set the numerator equal to 0. So that means x plus 1 is 0, so x is negative 1. So my x-intercept is negative 1, 0. The y-intercept set the x is equal to 0. So those are gone. So I just have 1 over negative 4, which is negative 4. So my y-intercept is 0, negative 4. Vertical asymptote, I set the denominator equal to 0. This is a difference of squares, x plus 2, x minus 2. So therefore, x is negative 2 and x is positive 2 are my two vertical asymptotes that I have here. And then horizontal, well, do I have one? Yes, I do. They're not the same power, so it's not the ratio in this case. The bigger number is in the denominator, so that means what? That means my horizontal asymptote, whenever there's a bigger power in the denominator, is always y equals 0. So that should be your answer for all of these. This is what the sketch should look like. And then for these guys, x-intercept is negative 1, 0, y-intercept 0, negative 4. Two vertical asymptotes, and the horizontal is equal to y equals 0. So if you guys have that, great. I'll let you go. I'll see you on Wednesday. If you don't have it, if you're still working, that's fine. Like I said, I'm not going to log off yet. I'll stick around. You guys can keep working it. If you get stuck, if you have a problem, then certainly feel free to type it in. Otherwise, I'll leave up the homework discussion thread for a few days at least. And if you want to type your question in there, that's fine too. Otherwise, if you guys got it, then I will see you on Wednesday. Have a good couple days. Be safe. And we'll see you then. Otherwise, if you guys are sticking around, I will stick around a little longer. All right. See you Wednesday. Yep. See you Wednesday, Amber. See you, Vanessa. All right, Brianna. See you later. All right, looks like nobody has a question. Numbers are dwindling down. If you do have a question, type the exclamation points real quick. Otherwise, I will end the stream and see you guys on Wednesday. All right, you guys have a good night.